Hi, in this video we'll be talking about named tuples. Well, you sure know what tuples are. Tuples are immutable and we can access their elements by index. On the other hand, we have dictionaries where we can access elements by case and classes where we can use attributes with meaningful names. This is often more readable than indices. Named tuples sort of combine the two ways of accessing elements. We can use both indices and attribute names. To see the difference between a regular tuple and a named tuple, let's first create a simple program with a regular one. So here we have a simple regular tuple which contains the following elements: a string, an integer, and a list of 3 integers. And here we're using the print function to print a formatted string that contains these elements. And we are getting these elements by index. So index 0 refers to this string. Index 1 refers to this string, and so on. Here in the for loop, we're looping over these 3 additions. Book with index 3 refers to this element, and printing them out. Now let's run this program. So, Furious Tapeworms by Mary Rumble, 1521 pages, fascinating pages, and here are the additions. And now let's rewrite this program replacing the tuple with a named tuple. In order to use named tuples, we have to import the extension type named tuple from the collections module. So let's do it. From collections, import named tuple. And now we have to use the factory method named tuple like so. Book equals named tuple book title author. As you can see, these are the names of the attributes we want to use. Page count, additions. So a named tuple requires at least 2 arguments: type name and field names. Named tuple is a factory function which returns a new tuple subclass with a name specified as the type name argument, in our case book. The second argument, field names, over here, is a sequence of strings. The subclass returned by the named tuple factory function is used to create objects that behave like tuples, but their elements can be accessed not only by indices but also by attribute names specified as the strings in the field names sequence over here. So in our case, the elements can be accessed by means of the attribute names like title, author, page count, and additions. Fine. Now we can rewrite our code like so. Book equals book, and here we can use the keyword arguments. Title equals Furious Tapeworms. Author equals Mary Rumble. Page count equals 1521. And additions equals, and here we have the 3 additions. Now here we are accessing the elements of the tuple book by index, just like before. So 0, 1, 2, and so on. Let's run this code. and we get the same result. But we could, instead of these indices, use these attributes. So we could use something like book.title, book.author. So it works, it looks like attributes in a class. Book.page count, and here we can use book.additions. And now if we run the code, the output is the same. Furious Tapeworms by Mary Rumble, 1521 pages, fascinating pages, editions, and so on. Now in this example, the field names argument is a list of strings, but alternatively we could use a string. If so, we'd have to separate the attribute names with white spaces. So we could get rid of the square brackets, and now what we need is just white spaces between the attribute names. And this should also work. Let's try it out. Yeah, it works too. So here we are instantiating our name tuple with keyword arguments. But we could also use positional arguments. So we don't have to use the keywords arguments. And this should work as well. Just like any positional arguments. Is the title, author, page count, and additions. Let's try it out. Yeah, works too. Or we can use both positional and keyword arguments. In such a case, the positional ones must of course come first. So for example, these two can be left as is, which means they are now positional arguments. And these two may be used as keyword arguments. Page count equals and additions equals. Fine. And this should work too. Yeah, sure. And now let's use our example in interactive mode to demonstrate how name tuples can be used. So let me now send this to interactive mode. Fine. And now, for example, we can use indices, just like with regular tuples. Book with index 1, book with index 3, 0. So index 3 refers to editions and 0 to the first edition. And here's the output. Mary Rumble and the first edition. We can also access the elements by attribute names. So book author, book editions, and now we need the edition at index 0. And here's the output. We can also use unpacking. So we can unpack this tuple, and the elements of this tuple should be assigned to these 4 variables: book title, book author, book pages, and book editions. Okay, and now we can just check it out. So let's print our book title, book author, book pages, and book editions. And here we get it. Title, author, pages, editions. Now if we print our book tuple like so, we get a readable string representation. Title equals Furious Tapeworms, author equals Merry Rumble, and so on. Finally, let's mention the methods we can use with named tuples. We can use all the methods inherited from the tuple class, but also some more. So the first typically named tuple method is _make. We use it to create a named tuple from a sequence or iterable. So, for example, here we have a list. And this list contains, again, two strings, an integer, and a list of integers. And now we want to make a named tuple out of this list. So we can use it like so. Book, this was defined before, dot underscore make, and here we pass our a list. And here we have our named tuple. Title equals Furious Tapeworms Part 2, author the same as before, page count. Now this book was so interesting that the author decided to write more about this topic, and there are 2 editions, right? Or we can use a tuple, and here we have the elements, a string, another string, an integer again, and a list of 2 integers. Fine. And now we want to make a named tuple out of this regular tuple. So what we have to do is book dot underscore make, and here we pass our a tuple. And here we have it, a named tuple, again in a readable format. We can even use a string or a range if it makes sense. It doesn't make sense here, but at least you can see how it works. So let's suppose we have a string like so, A, P, 6, 2. Now we can use the underscore make function like so, book dot underscore make, and we can pass our string, a string, to the function, and here's what you get. Title equals A, author equals P, page count equals 6, editions equals 2. Well, it doesn't make much sense here, but this is how it works. In other cases, it might make more sense. Or we can use a range. So, a range equals, let's say, range with argument 4, which means numbers from 0 to 3. And now we can use our underscore make method like so, book dot underscore make, and we can pass our a range over here, and this is what you get. Title equals 0, author equals 1, and so on. Let me mention just one more method, underscore as dict. It returns an ordered dictionary, so a dictionary containing key-value pairs, which additionally takes into consideration the order the elements were added in. Here's how it works. Here we have our named tuple, book. And now let's use our underscore as dict method like so. Book dot underscore as dict. And here we get an ordered dictionary. So a dictionary where the order is important. Now we can see the whole of it. If the need arises, you can make a regular dictionary like so. Dict book dot. So we can pass our ordered dictionary to our dict function. And now what we get is a regular dictionary. Title, Furious Tapeworms, author, Merry Rumble, and so on. Now, if we have a regular dictionary, which we want to turn into a named tuple, we can use the ** operator. So here we have a dictionary, my favorite book, title, author, page count, editions. And now we want to turn this into a named tuple. So what we have to do is book, and here we are using the star operator with the name of the dictionary, my favorite book, and this is what we get, a named tuple. Title equals Sarah Strikes Back, author Ben Struck, page count 425, and here are the editions. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.